Good day everyone, welcome to BSABE-A Tutorials. In this video, we will solve a fluid mechanics problem from the book of Yunus A. Sengel and John M. Simbala, Chapter 6, Review Problem 6-85. So in this problem, a walnut with a mass of 50 grams, so imagine this is the walnut, requires a force of 200 Newton applied continuously for 0.002 seconds to be cracked. If walnuts are to be cracked by dropping them, if this walnut will be dropped from a high place onto a hard surface, let's say this is the surface, determine the minimum height required. So we will determine the minimum height required. Disregard air friction. So in this problem, the givens are mass is equal to 50 grams, the force is equal to 200 Newton. The time it takes is 0.002 seconds. So in order to solve this problem, a walnut is to be cracked by dropping it from a certain height to a hard surface. So this is the walnut, this is the surface, this will be dropped. So you can imagine the minimum height is required is to be determined. So for our assumption, the force remains constant during the cracking period of the walnut. So the air resistance is negligible. So for our analysis, we take the x-axis as the upward vertical direction. And the Newton's second law of motion, which is F is equals to mass times acceleration is equals to mdv over dt, can be expressed as force times the change in time is equal to mass times the change in velocity is equals to mass times the velocity of the strike minus the final velocity. So this is equal to the strike velocity is equals to force times the change in time over mass. So since the force remains constant and the final velocity is 0, substituting the values, we have the velocity strike is equal to force times the change in time over mass. So we have 200 Newton times 0.002 seconds all over by 0.050 kilogram multiplied by 1 kilogram times meter per square second over 1 Newton. So we get 8 meter per second. So for our initial potential energy is equal to the final kinetic energy. We have mass times gravity times height is equal to 1/2 mv squared is equal to h is equal to the v squared over 2g. So the elevation that will result at this value of velocity can be determined from the conversion of energy principle. In this case, potential energy being converted to kinetic energy to be initial potential energy is equal to final kinetic energy. So we get mass times gravity times height is equal to 1/2 times mass times the strike velocity squared becomes h is equal to strike velocity squared over 2g. So substituting the required height at which the walnut needs to be dropped becomes h is equal to velocity strike squared over 2g is equal to 8 meter per second squared divided by 2 times the gravity, which is equal to 9.81 meter per square second, we get 3.26 meter. So the height required is 3.26 meters. So this is our final answer. So note that a greater height will be required in reality because of air friction. So that's it for today's video. Thanks for watching. See you again in our next one. Happy learning!